Good afternoon and welcome to the SCSA's Toolbox Tuesday. My name is Justin Brooks, Safety Advisor for the SCSA, and I'll be presenting today's Toolbox Talk. So before I start the presentation, I just want to take a moment to discuss a few items before we get going. This Toolbox Talk is being recorded and will be available for later viewing on our Facebook and YouTube channel. So if you're not following our social media accounts, make sure after this Toolbox Talk you give this video a like and a share. Follow our pages to keep up to date on safety in Saskatchewan. So what I'm going to do here is I'm going to bring up my PowerPoint here on electrical safety, but first I must share my screen. All right, here we go, electrical safety. So again, good morning and welcome to our Toolbox Tuesday. Today we'll be talking about electrical safety and emergency programs for workers who may come in contact with an exposed energized electrical conductor. So while it's true that electricity always seeks the easiest path to the ground, that's not the only path it takes. Electricity takes every path to the ground, whether it comes from a household lighting circuit, a high power transmission line, or lighting. If a person touches two energized wires, an energized wire, and the ground at the same time, he or she will become part of an electrical circuit, may be killed or injured. Electricity is generated by power plants at voltages ranging from 2300 to 20,000 volts. This voltage goes through a transformer and is stepped up for efficient transmission over long distances to switching stations. Some transmission lines operate as low as 72,000 volts, other as high as 230,000 volts. At the switching stations, voltage is reduced and power is sent on distribution lines to industrial, commercial, and residential customers. So before we get right into the thick of it, let's discuss some definitions associated with electrical work. Many electrical terms that describe how electricity travels can actually be likened to the passage of water. So first off, let's talk about voltage. It's similar to water pressure. It's the force that causes the flow of electricity. Current can be likened to the rate of flow of water in a pipe. Resistance is similar to the effect of friction on the flow of water in the pipe. So the water flows more freely in a large pipe than a small one. Different materials have different resistances to the flow of electricity. Very high resistance materials are called insulators, while the low materials are called conductors. In an electrical system, the force or pressure is measured in volts and the current flow in amps. Resistance is measured in ohms. So let's talk about those insulators, conductors, and semiconductors. So all materials conduct electricity, but in varying degrees. Materials classified as insulators conduct electricity in such small quantities cannot normally be detected. On the other hand, materials classified as conductors conduct electricity readily in large amounts. To cite two examples, glass is an insulator, metal is a conductor. Now, there are some in between. You'll see in this picture here, the in-betweeners are kind of set into the two columns, and that's fine between conductors and insulators, as long as you understand how this works. So some other materials are classified technically as semiconductors. These include things like water, wood, earth, and rubber tires. So this all depends on conditions, so like things like moisture content and contaminants. Semiconductors can conduct large amounts of electricity if all the conditions are right. So you'll see I have like rubber in the 5 electrical insulators, and then we have water in conductors. These all kind of depend on the conditions at the time. Low voltage hazards. So now most electrical fires originate in equipment operating below 750 volts. In the electricity industry, this is referred to as low voltage. Home heating systems and home appliances operate at 240 volts or less. Although the hazard is greater with high voltage installations, it's important for first aid personnel and workers to realize the hazards of even relatively low voltage. So voltage gradient on the ground surface. So now because electricity always takes every available path to the ground, electrical systems use conductive grounding rods to ensure that any stray electricity is returned to the earth safely. These rods are driven in about 2.5 meters or 8 feet or more into the ground to ensure deep dispersal of the current. However, if electricity is released into the ground surface, such as when a live wire lands on the ground, the electricity will actually fan out from the point of contact. There's a rippling effect that can be likened again to water, in dropping a pebble into calm water or lake. In the pool of water, the wave that's created at the point of contact gets smaller as it rings out. Similarly, in this pool of electricity, the energy is at full system voltage at the point of ground contact, so where the wire is laying. But as you move away from the contact point, the voltage actually drops progressively. This effect is known as ground gradient, and knowledge of how this works may actually someday save your life. So on that topic, we'll speak on step potential and touch potential. More on step potential. The ground gradient or voltage drop creates problems known as step potential. Let us assume that electrically charged wire is touching the ground and has created a pool of electricity. So now if you replace 1 foot near the point of ground contact, so at like the X voltage, and your other foot a step away at the Y voltage, the difference in potential or voltage would cause electricity to actually flow through your body. This effect is referred to as the step potential. Now, having said that, if there's an emergency circumstance where you don't feel confident in being able to reach the subject, the first step is always cut the power or contact someone that can cut the power. As much as I'd love to say that you want to jump in there and help your fellow coworker, you don't need 2 bodies laying on the ground. So obviously, if you can't cut the power, contact someone who can. Now, faulty electrical equipment. So it's obvious that electricity is safe when it's properly controlled. However, hazards are created when electrical equipment or wires have become faulty as a result of being worn out and deteriorated, improperly installed, improperly maintained, or even just broken. Any one of the above may cause arcing or overheating of electrical equipment, the 2 conditions that cause the majority of electrical fires. An electrical arc is a sudden flash of electricity between 2 points of contact. An arc is extremely hot and can ignite combustible material in the vicinity, including some insulation materials around the conductor. Hot material may be thrown into the adjacent flammable material, starting a fire. The majority of fires caused by overheating result from overloading electrical conductors and motors. The amount of current exceeds that which conductors and equipment are designed to carry, dangerous situations are created. The effect of electricity on the body is dependent on actually the amount of current and the length of time the body is exposed to it, not just electricity in general. The higher the current, the less time a human can actually survive the exposure. The path of electricity through the body is also crucial. So, for example, current passing through the heart or the brain is more life-threatening than a current passing through the fingers. Most common household currents are 1 to 2 amps. So, for example, it takes approximately 1 amp of current to run a 100-watt light. That's 1,000 milliamps. Even a fraction of that for a few seconds or more could be fatal. So here on this picture are some of the effects you can expect from just a few seconds of current, and this is in milliamps, right? So as we go, we kind of spoke about 100 milliamps, or pardon me, correction, 1,000 milliamps and 100 watts. So this is in milliamps as to what could happen. So it's the amperage that kills or injures, but the voltage, which pushes the current through the body, also has an important effect. When a person is exposed to household voltages, he or she may suffer a muscle spasm and become locked on an electrical source until the circuit is turned off, or until the victim falls clear from the weight of his or her body. Relatively long periods of contact with low voltage are the cause of many electrical fatalities in the home. Very high voltages on power lines, for example, the victim is often quickly blasted clear the circuit. This may result in less internal damage, but terrible surface burns at the entrance and exit points of the current. A person exposed to a large electric arc can be injured by the intense heat or by the ultraviolet rays, which can cause serious eye damage. The effect of electricity on the body also depends on the condition of the skin and the area of skin exposed to the electrical source and the pressure of the body against the source. Severity of the shock will be increased if the electric current touches moist or broken skin. Any victim of electrical shock should be examined for the following effects on the body. So we have things like cardiac arrest, temporary paralysis of the respiratory center causing breathing failure. We have burns to tissue at the current entrance and exit points. So these are mainly resulting, again, from higher voltage, but still it's important to look. and fractures caused by muscle spasms, right? Or even being thrown. So keep in mind that the danger, again, has to be removed before any treatment can be given to the injured worker. In some cases, a circuit can be turned off, and in other cases, it can't. Electricity always seeks every available path to the ground. If you touch an energized wire and the ground at the same time, you may be killed or injured. So now that we understand a little bit more about electricity and the dangers of it and some of the outcomes, this brings us to my next point. So in the Saskatchewan Occupational Regulations, section 3018, it states, if an electrical worker may come in contact with an exposed energized electrical conductor and that contact may affect the health or safety of the worker, an employer contractor shall develop and implement an emergency program that sets out the procedures to be followed in the event of contact. And we'll go through the whole piece of legislation now, and we're going to break it up here. So in 2, an emergency program developed pursuant to subsection 1, which I just read, must include procedures: A, to rescue a worker who has come in contact with a live conductor; B, to administer first aid to a worker who has sustained an electric shock; and C, to obtain medical assistance. And 3, 3018.3 states an employer contractor shall ensure that the workers are adequately trained to implement the emergency program. So let's just break this down just a little bit. Let's start with the first one, which states an electrical worker may come in contact with an exposed energized electrical conductor, and that contact may affect the health or safety of a worker. An employer contractor shall develop and implement an emergency program that sets out the procedures to be followed in the event of contact. So, first step, what is an exposed energized electrical conductor? Energized means it's electrically connected to or having a source of voltage or electricity charged to have a potentially significant difference from the earth in the vicinity. So note that de-energized parts that have not been verified and locked out and tagged in accordance with established standards are considered energized. And exposed, so as applied to live parts, capable of being inadvertently touched or approached nearer than a safe distance by a person. It is applied to parts that are not suitably guarded, isolated, or insulated. Simply speaking, an exposed energized conductor is when a person can inadvertently make contact with an energized conductor or circuit part. So like an example of this would be having like the front cover completely removed off an electrical panel. There's no safeguarding, it's live, and if it's not tagged out, we assume that it's live, and it's an electrical conductor and it's exposed. So that would be the best example I can give at this moment. So what this piece of legislation is telling us is that if any point during a worker's time on the job, they can come in contact with an exposed energized electrical conductor, you need to have a written procedure to deal with everything. So you need to be able to deal with, like we had talked about in 3018.2, it must be developed in pursuant to subsection 1, and it must include plan to rescue workers who have come into contact with a live conductor, to administer first aid to a worker who has sustained electric shock, to obtain medical assistance. So we know the procedure, like, do we know the procedure to rescue a worker? If you don't, you have to create one. If you don't have one, you have to make one. You also have to have the workers understand the first aid requiring in dealing with someone who has sustained an electric shock. It is absolutely imperative that you understand the regulations regarding first aid training. And finally, obtaining medical assistance. So questions that have to be answered is, how far are you away from a hospital or somewhere with staff that have a medical practitioner available? And how will you get them there? Can you call? Do you have service, available service? Are you out of town? All these things need to be in an emergency plan, and the emergency plan is going to be rather fluid depending on where you are. Again, we've kind of went through some of those parameters. If you work one job that's an hour and a half away from a hospital, and you work at another job that's 15 minutes away, a lot of those procedures are going to be relatively the same depending on certain circumstances. But it's that getting that person to medical assistance. That's going to be the big one that's going to be changing depending on where you are. It could also change between the time of day. The availability of staff. Are there people working with them? Is it an isolated worker? There's a lot of things that need to be taken into effect. So this isn't just a one-page, easy does it type of document. And then when we talk about number 3, an employer contractor shall ensure that the workers are adequately trained to implement an emergency program. So are they trained? This is a huge part of your emergency system. Every worker needs to understand what to do in an emergency and what role they play. That's why it's so important that companies are actually proactive when creating these emergency response procedures. Time is of the essence when dealing with a medical emergency, and the workers need to have the skills to deal with them if they were to arise. It's important to note that creating this emergency response plan isn't something you want to pull from Google or even another company. Although this may give you a template of sorts to work with, it's imperative that this is created by you for your company. Doing so will give you more ownership over the program and you will understand it more deeply. This will allow you to have a level of understanding over the program that will translate over to your workers. It's also important that you practice these emergency procedures regularly. Workers need to be able to react in a situation that requires them to move quick. If you're having trouble or unsure on where to start when creating emergency preparedness procedures, contact us here at Advisory Services and we can help guide you through the process. So this concludes our Toolbox Tuesday. I'd just like to take a moment to thank all of you for watching. By watching and participating in these discussions, we're all working together making Saskatchewan the safest construction environment in Canada. Make sure you tune in next week for Toolbox Tuesday at 10 a.m. And just a reminder that our Wednesday webinars will be on the first Wednesday of every month at noon. Also want to remind everyone that we have our webinar presentations and Toolbox Talks available on our YouTube channel. These are a fantastic resource for training in Toolbox Talks, especially if, like us, you're doing your meetings online. Remember to like and share this video and follow us on all our social media platforms. Have a great day, everyone, and work safe.